Welcome to Module 3 of this beginner cybersecurity course. In this module, we are going to explore the building blocks of how computers work, their operating systems, and file systems. As a future cybersecurity professional, you need to understand how both Linux and Windows function under the hood, how permissions control access, and how to read system logs to spot signs of compromise. Let's get started. By the end of this module, you will be able to explain the key differences between Linux and Windows OS, navigate file systems and interpret permission structures, use basic command line tools for analysis, understand the role of system logs in threat detection, complete a practical OS level investigation using logs and permission. What is an operating system? An operating system is a system software that manages computer hardware and software resources and provides common services for computer programs. Simply put, an OS is the master controller of your computer. Think of it as the manager of a large hotel. It oversees the rooms, the guests, and the employees. In this scenario, the rooms can be likened to your computer memory, the guests can be likened to your computer programs, and the employees can be likened to the different processes that run on your computer system. Windows and Linux are the two dominant operating systems in cybersecurity environments. Each has different internal structures, file systems, user roles, and login mechanisms. Windows uses NTFS, registry, and event viewer. Linux relies on ext4, etc/pass wd, and var/log. Linux emphasizes modularity and transparency. Windows emphasizes user experience and centralization. As a cybersecurity professional, you will encounter both, especially in mixed enterprise environments. A file system is how the OS organizes and stores data. Think of it like a digital filing cabinet. NTFS Windows includes advanced features like file permissions and journaling. ext4 Linux is robust, fast, and used widely in servers. File paths and naming convention differ across OSs. Attackers often hide files in obscure directories or modify system files, so knowing where to look is vital. Every file and folder on a system has associated permissions, rules that define who can read, write, or execute them. In Linux, use ls-l to view permissions. Now, in Windows, permissions are handled through file properties and user roles, administrators, users, guests. Attackers often try to escalate their privileges by modifying permissions or accessing sensitive files. Monitoring changes to permissions is a key defensive technique. The command line is one of your most powerful tools as a security professional. In Linux, you will use commands like cat, grep, tail, and ps. In Windows, commands like task list, who am I, and net start are essential. The command line offers speed, control, and deep system visibility. You don't need to memorize everything, but you need to be comfortable navigating and executing basic commands. Processes are programs that are currently running, and some are user initiated, others are system services. In Linux, you can view them with ps, aux, or top. In Windows, use Task Manager or get processes in PowerShell. Malware often disguises itself as a legitimate process, like this, or runs under unusual user accounts. That's why understanding what should be running is key to spotting what shouldn't. System logs. System logs are a treasure trove of forensic data. Linux logs are stored in var/log directory and include auth logs and syslogs. Windows logs are accessed via Event Viewer and include security applications and system logs. So, logs tell the story of logins, file access, privilege escalation, and application errors. Reading logs is like reading a digital diary, and it's your job to find suspicious entries. As a cybersecurity professional, logs are often your first clue that something is wrong. Examples of what to look out for: failed login attempts, user privilege changes, system reboots or crashes, services starting or stopping unexpectedly. By combining logs with file system knowledge, you can piece together how an attack started and what it touched. Next, I'll be showing you how to set up a mini home lab which you can add to your portfolio projects. So we'll start by searching for Oracle VirtualBox. So Oracle VirtualBox is a general purpose full virtualization software. So you click it, you navigate to your downloads tab, then select which host machine you'll be having your VirtualBox on: Windows, Linux, Mac. Click it and start the downloads. Next, you have to download the VirtualBox extension pack, which helps the software work better. Download. Next, you search for Kali. That's what I did. When you search for Kali Linux is a pen testing OS that it comes pre-installed with all the tools you need. So you navigate to the downloads tab and go directly to virtual machines. So virtual machines have everything already pre-built and pre-packed for you. All you need to do is click on it, start the downloads. When that is done, then you extract it, usually in a zip file. Now you open your VirtualBox machine, click add, select your Kali box which you have extracted and add it to your VirtualBox manager. Okay, it's added. Next, okay, you can see the username and the password here. So it gives you that in the description. Next, we start the machine just so we can see what we're working with. Okay, so I'm going to skip the startup. Now you enter your login, Kali. So I already went ahead to create the folders and everything. So I'm just going to be showing the commands that I used to do that. So CD, I navigated to the folder I wanted it to be in. As you can see, Cybersecurity portfolio. This is the command I used to create this directory. Next, let's go into the directory and see what is in it. So this command is to navigate into the Cybersecurity portfolio directory. We are going to list again just to see. So I've done this. So I created this file and this is the content. So there will be a cheat sheet in the description showing you how to do all this. Well done, you've completed module 3, a major milestone in understanding how operating systems form the backbone of cybersecurity operations. Now let's review what you've learned in this module. You explored the key differences between Linux and Windows. You practiced using the command line to inspect permissions and processes. You learned how to locate and interpret system logs. You completed a practical project using your own VM. So these are foundational skills that will serve you through your cybersecurity journey. In the next module, we'll shift focus to networking fundamentals. Why is this important? How devices connect, how data flows, and how attackers take advantage of those systems. Thank you and see you in the next video.